Alright, so we are going to look at a bit of trigonometry for our right triangles now. So reading our learning target, it should say, I will be able to identify right triangles, so cross out the word special, and their side lengths so that I can determine the angles for problems and the house problem. So we are looking at the angles now using our trigonometry. So to help you figure out when we are using our different trig functions, as they'll be referred to, I want to introduce you to Focus Angle Frank, this wonderful stick figure dude. He's going to help us identify the focus angle when we're looking at a right triangle. So when you look at your right triangle, your focus angle is usually going to be an angle given to you. We're not really going to be looking at that 90-degree angle. That's just there to tell us it's a right triangle. So our focus angle here, I'm going to draw Focus Frank right there. And now I want to mark which sides in my triangle are the opposite, adjacent, and hypotenuse compared to Focus Frank. So the opposite side over here is across from him. Adjacent is a fancy word for next to, so you can tell that this side is right next to him. So I'm going to put an A. And then we know that our hypotenuse is this side across from the 90-degree angle always. So that is just a very beginning introduction to it. Let's try it again over here. Again, I'm going to draw in Focus Frank at my focus angle. My opposite side is going to be across from Focus Frank. Adjacent will be right next to him. And my hypotenuse is always across from the 90-degree angle. So the adjacent side is just one of the legs of the triangle. It's not the hypotenuse. So be careful you don't mix these two up. And I'm going to jot right here too, Frank, our focus angle guy, he is not the 90-degree angle. He's always going to be at the other angle. Alright, so letting our papers down a little bit, we are just going to do some more practice here with Focus Frank. So instead of having an angle measure, now I have X. So I'm going to draw in Frank and mark that Frank is opposite of this side, adjacent to this side, and our hypotenuse right there, across from the 90-degree angle. You try these next two and then check them off of what I do here on the video. So we've got our opposite, adjacent, and hypotenuse. First I need to draw in Frank, opposite, adjacent, hypotenuse. So just like we were labeling side relationships in special right triangles, this is a really useful thing to label in trig problems so that you know which sides are which. Alright, so next we're going to look at the three trig functions. This is a little memory tool for us to use. It's called SOHCAHTOA. You just read it like it says, SOHCAHTOA. So I'm going to put some arrows here to remind you that that is super important and will help you with what we're about to do next. So if we look at these problems, I've got Focus Frank here at my focus angle. The first thing I want to do is fill in my opposite, adjacent, and hypotenuse. And now I've got these fancy trig functions. So this one is read as sine, this is cosine, and this is tangent. So just like how multiplying, dividing, adding, subtracting, all of those are operations that you can do to numbers, sine, cosine, and tangent are kind of like that. So we're looking at the sine of Focus Frank, the sine of the angle. So Focus Frank is always going to be an angle measure. And we've got SOHCAHTOA to help us know which sides to fill in. That creates that sine relationship. So again, just like in special right triangles, all of this stuff is something that mathematicians a long time ago figured out to be true by looking at lots and lots of right triangles and identifying this pattern. So we can just know that SOHCAHTOA is true and use it to help us in problems. So all I'm going to fill in here is that SOHCAHTOA is opposite side over adjacent. So cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So I have SOHCAHTOA. And just saying that is going to be a good memory tool for you on tests. Alright, looking at a more specific example here, we want to identify OA and H and figure out which trig function can be used to solve for x. So of course we need to solve for x in these problems. It is not just as easy as drawing focus Frank everywhere. But we are going to do that first. So I draw him in right there, and I label my opposite, adjacent, and hypotenuse sides. Well, now if you look at it, I see that I have an x here and a 3 here. So I'm looking at the O and the A. If I look at these three trig functions, the O and the A go with tangent. So I know that I need to use tangent here. So I can write that the tangent of focus Frank equals opposite over adjacent. Now I can fill that in with the numbers and the variable. So the tangent of 35 degrees, because that is the focus angle, is equal to the opposite, which is 3, over the adjacent, which is x. And that's it. In just a little bit, we're going to solve for x, but first we'll leave this as it is. All right, if we slide our paper down, we can look at a couple more examples like that here. So again, I want to draw my focus Frank angle and identify the opposite, adjacent, and hypotenuse. I see I'm looking at the A and the H because that's where I have a number or variable given to me in the problem. So A and H up here with SOHCAHTOA goes with the C for cosine. So I have that cosine of focus Frank is equal to A over H. Or if I fill that in, the cosine of 35 is equal to x over 6. All right, let's look at the next one. I draw in focus Frank where my angle is. I label O, A, and H. Now I want to look at the sides where a number or a variable is given to me. So I have O and H identified here. So up here when I look at my three options, O and H are with sine. So I'm going to circle that. And write in that sine of focus Frank is opposite over hypotenuse. If I fill in those values, I have sine of 35 degrees equals 13 over x. All right, let's try the last two here. So focus Frank is moving up here this time, where the 55 is. My opposite, adjacent, and hypotenuse. I can circle where I see my variables and my numbers. A and H tells me that I need to be using cosine, so I can circle cosine. And now instead of writing cosine focus Frank, I'm just going to move on to that next step we did here and say that cosine of 55 is equal to adjacent over hypotenuse, which is 13 over x. So you're welcome to write this step out each time if that helps you, or you can jump right to this step, which is what I did here. All right, last one on the front. We've got focus Frank down in this corner. I've got my opposite, adjacent, and hypotenuse. I circle the sides that have a number or a variable. And I see I have O and A. So O and A is going to be tangent. So I have that the tangent of 55 degrees equals opposite over adjacent, so 7 over x. Like I said, we're not going to solve those now, but you will be solving these in class. Go ahead and flip it over. There is just one more thing that I want to show you, and then I'll see you in class. Alright, so this whole top part here we're going to talk more about, but it has to do with how you are going to type these problems into your calculator. So again, we'll talk more about this in class, but it just tells you that your mode of your calculator needs to be in degree, and then that your buttons here are what you can use. So if you would like to go ahead and just type in these numbers to see that you're going to get some decimals, then that's okay, or you can wait and do it in class. Alright, I want to go ahead and solve some of these all together. So I'm going to first draw in my focus Frank. label my opposite, adjacent, and hypotenuse just like what we were doing on the front. Still, just like what we were doing on the front, I'm circling those sides that have a variable or number. I have O and H, so SOHCAHTOA tells me that it is sine, so I have that sine of focus franc is opposite over hypotenuse. So I can write that sine of 38 degrees equals opposite over hypotenuse, which is x over 4. Alright, now comes the solving part of this. So to solve this, what we are going to do every single time we have trig functions is put our trig function over 1, so that now we have two fractions, two ratios. And just like we did with similar triangles, we can cross multiply those ratios to help us solve for x. So I have x times 1 gives me x, and sine of 38 times 4. I always want to put the number before the trig function. So I'm going to write that 4 times sine of 38. Writing the number first just helps you not get this number confused with whatever your angle measure is. Alright, now we just type this in our calculator. So you type 4 times the sine button and then 38. And you should end up with x equals 2.46. And if you round that to the nearest tenth, the 6 makes the 4 round up to a 5. Alright, I promise you this is the very last problem and then we are done with the notes. Let's do this next one. Draw in your focus franc. Label your opposite, adjacent, and hypotenuse. I'm going to circle those sides that have a number or variable. I see I have A and H circled, so that gives me cosine. So now I need to write in that cosine of 25, which is my angle, is adjacent over hypotenuse because it's from SOHCAHTOA. So 14 over x. Alright, next up we need to put cosine of 25 over 1 so that I can now cross multiply my proportion here. So this time I end up with 14 times 1 gives me 14 is equal to cosine of 25 times x. So just like how we wrote the number first, I'm going to write the x first so that I'm not getting it confused with the angle measure. If I want to solve for x here, I need to get it by itself. Since it was being multiplied here, it's being multiplied here. The opposite of multiply, as you know, is divide. So we can just divide by the whole thing cosine of 25 degrees. Dividing by that, these cancel on this side. And so you get that x equals 14 divided by cosine of 25. And once you type that in your calculator, you end up with 15.44 equals x. Alright, great job everybody. Thank you for watching.